Okay, we're looking at area between two curves again.
Yeah.
The first two problems we look at are going to be slightly different than what we did yesterday, but similar. And then the last two problems we look at, we're going to use our calculator to evaluate. So, first problem is let the shaded region R, the shaded region R is bounded by the graph of x equals 4 minus y squared and x equals y minus 2, as shown in the figure. Find the area of R. How is this problem different than the problems we worked yesterday?
Equals like sideways.
Okay, it's kind of
And it's x equals.
it's x equals and it's kind of sideways.
We need to change it to y equals.
We don't need to change it to y equals. We can keep it as x equals. Okay. What was the process of what we did yesterday?
Integrate and divide the.
What did we do before we integrated?
Figure out which one.
No.
Starting stopping point.
We figured out the starting and stopping point. How do we do that?
By
Setting.
the graph.
Set them equal. Okay. Then what do we do?
And then figure out which one's on top.
Figure out which one's on top. Okay. And then that had to come first. Then we integrated and solved it. So this one's going to start the same way. We need to set it equal to each other to figure out our starting and stopping point. But instead of doing the top minus the bottom, what do you think we need to do?
Right minus left.
We need to do the right minus left. Okay. So those are the two differences on this type of problem. So like we said, what's the first thing we need to do to it?
Set them equal.
Set them equal. So we're going to have 4 minus y squared equals y minus 2. Okay, how are we going to solve that?
You get to y squared.
I move everything to the right is what I would do.
Yeah.
Okay, we need to factor it. How's that factor?
3 2 plus 3 minus
So that means my starting and stopping points will be
2. Negative 3 and 2.
-3 and 2. Okay. Then what do we need to know?
Which one's on top?
Except
Left. Which one's left? Or the right?
which one's right? Right's going to be the same as on top. So which one's going to be on the right?
The x equals 4 minus y squared.
The 4 minus y squared. Any issues with seeing which one was on the right? Okay, clean that up a little bit. So that's going to be 6 minus y squared minus y dy. If I integrate it, it's going to be 6 y minus y cubed over 3 minus y squared over 2. Plug in the 2 first. So that's going to be 12 minus 8 over 3 minus 2. Plug in the -3, that's -18 plus 9 minus 9 over 2. All right, on the inside, the -18 and the 9 turn into -9, but this negative turns it into a +9. The 12 and the -2 is a 10, so the +9 and the 10 make it 19 minus 8/3 plus 9/2. Okay, and again, if this is free response, I can stop right here, but we want to go ahead and get an answer for now. So what do I need to do to be able to get an answer from here? Common denominator, what's it going to be? 6. So I need 6 times 19.
124? No, I'm way off.
114. What do I need to multiply the 8 by?
2,
2, which makes it 16, and multiply the 9 by
3.
3, which makes it 27.
122.
So I end up with 125 over 7, or over 6. What does 125 over 6 represent?
The area in between the two.
The area in between. Okay, let's move to the next one.
Chris, you were close. Yeah, that too. I did look at that.
All right, on this one. Let R be the region bounded by the graph of f of y equals 3 minus y squared, and the graph of f of y equals y plus 1. Find the area of R. So what do I do to get started? Set them equal. Again, it'll be easier to move everything to the right. How's that factor?
Plus 2 minus 1.
Plus 2 minus 1. So my limits will be
-2.
negative 2 and 1. Okay, how do I know which one's on the right? Just like we did yesterday, plug in the numbers. So what's the best number to plug in?
0.
0. Plug in 0 to the first one gives me 3. Plug in 0 to the second one gives me 1. So that means the first one needs to come first. Alright, clean it up a little bit. So it's going to be 2 minus y squared minus y. Integrate, we get 2y minus y cubed over 3 minus y squared over 2, negative 2 to 1. Plug in 1, so it's going to be 2 minus 1/3 minus 1/2. Plug in negative 2, that's negative 4, plus 8/3 minus 2. So on the inside, negative 4, negative 2 is negative 6, but it turns positive, so 6 and 2 ends up giving me an 8. I've got an 8/3 on the inside, which turns into a negative 8/3, negative 8/3, and negative 1/3.
3. -3.
Negative 3. And then I have the minus 1/2. 8 minus 3 is 5, and 5 minus 1/2. 4.5.
9.
9/2 or 4.5, yeah. Same thing. But again, if it's free response, I can stop right there if I want. All right, the 2 on the back, need a calculator. Okay, use your calculator on the next 2. And borrow one. Didn't I tell you guys yesterday to bring?
Yeah. Oh, we have to use our calculator.
Alright, so we're going to use our calculators. It says find the area of the regions bounded by the graphs of f of x equals x times x squared minus 3x plus 3 and f of x equals x squared. So if I'm going to use my calculator, what do I want to do first? We want to graph both of these. So we're going to add a graph. Oops. Add a graph. Now what do I do? What should I do on that first one instead of plugging it in like they have?
You can tell the X.
Yeah, distribute the x is what I would do. So x cubed,
I just did X times in parentheses.
yeah, that's fine, you can do that too. Minus 3x squared and plus 3x. Press enter. So there's my first graph. What do I do to be able to put in a second graph?
Tab and then
Press tab, and that's just x squared. So there it is. How many regions are there?
reasons.
Regions. How many regions are there?
2.
There's 2. Okay.
Because it crosses up above somewhere.
Yeah. It crosses. We got a region right here on the left, and then there's a region on the right. Okay. Now that I have them graphed, what do I want to do?
You figure starting and stopping points of both regions.
I need to figure out my starting and stopping points. So how do I figure that out?
It's where they're semicolon each other.
How do I do that with a calculator, though? I don't want to do that.
You don't
What am I interested in?
Oh, you can just put the intersection.
I want the intersection points.
Forgot I cheated yesterday.
So how do I do the intersection points?
Menu, analyze graph.
Menu, analyze graph,
and
which
then
is 6.
goes Intersection.
Intersection is 4. Put that little hand on the left. Okay, now do not press in the middle of the big button. When you're on the left and you like it, press enter. Then you move it over. When you're on the right, press enter. Okay, do not press in the middle of that. It'll work, but sometimes if you do it incorrectly, it's going to give you a bad answer. So there's the first intersection. Now I want the second intersection. So I need menu, I need analyze graph, I need intersection. So just on the left of the next one, press enter. Just on the right, press enter. So now I have 2 intersections. And I've got 1 more to go. So menu, 6, 4. We want to be on the left, press enter. On the right, press enter.
Even zoomed it out.
All right, so how many integrals will I need?
2.
2. Okay, and the first one's going to go from where to where?
0 to 1.
0 to 1, and what needs to be on top?
The blue line. X. No. The big.
The x cubed needs to be on top. So the first one is from 0 to 1. And the x cubed needs to be on top. Okay, where's the second one going to go from?
1 to 3.
1, 2, 3. And which one needs to be on top on that one?
The X squared.
Now, even though you're using a calculator, you must show this setup right here. They will not give you any credit unless you show the setup. Okay, now, if we're going to use a calculator, we need to notice something. Notice that the x cubed function is called f1 and the x squared function is called f2. So, I want to identify that. I want to notice that the x cubed is f1 and the x squared is f2.
I want to note that.
Yes, you want to note that because when you put it in the calculator, that's what you're going to use. Okay? So now, let's go to the calculator. I need a new screen. How do I get to a new page?
Control document.
Control document. And this time, whoops, I must not have meant the control. I put tab, that was my problem. Control document. And I just want a calculator page. What's the shortcut to get to the integral symbol?
Shift plus.
Shift plus.
Yeah.
Okay, the first one was going from where to where?
0 to 1.
0 to 1. Okay, and which function comes first?
F1.
F1 comes first.
Yeah.
So what you want to do is press this variables button, and notice it gives you the option of F1 and F2. So I select F1, I put an X inside of it. Then I get outside. Then I want to subtract F2. So I do my variables, I want F2, put an X inside of it, and then go and put a DX there. So that takes care of the first interval.
I like this one better.
Okay, then go plus. I need my second integral, so we go shift plus. This one's going going from where to where?
1 and 3.
1 to 3, but this time which one comes first? F2. So I do my variables. I do F2. Then I do minus my variables. I want F1. Make sure we put an X on it. We press enter, and we have our answer. How many decimals do we want? 3. So my answer to that problem would be 3.083. Questions on that? Okay, let's look at the last one. Okay, find the area of the regions bounded by the graphs of f of x equals x to the fourth minus 4x squared and f of x equals x squared minus 4. All right, now whenever I change from one problem to the next, I always like to go home and start a new document.
Control N.
Control N does the same thing.
Yeah.
But what a new graph. And my first function was x to the fourth. And minus 4x squared. Press enter. Okay, what do I do to be able to get in another equation? Tab. And the other one is x squared minus 4. Press enter. I'm going to go ahead and zoom in a little bit. So I'm going to do menu, I'm going to do window, and I'm going to zoom in. And then I'm going to click where I want to zoom in. That gives me a little bit better view. When I'm done zooming, I press escape. Okay, so let's make some observations about this thing to make it as easy and efficient as possible to do this with my calculator. What do you guys notice?
There's 2 regions.
I thought there's 3 regions to me.
It, on one part of it, one is on the bottom or top, and on the other function is.
Okay.
I worded that badly, but
What else do we notice?
It's symmetrical across the y-axis.
That's what we want to notice. It's symmetrical across the y-axis. So that means I can just worry about the left side and do what to take care of the right side?
Double it.
Multiply by 2. So that's what I want to do. So I need to find my intersections first. So we go menu, we go analyze graph, and intersections. So I press enter. I move over. Press enter. I do it again. Menu, 6, 4. Enter on the left, enter on the right. And once I have those 2 intersections, I've got enough. I've got everything I need. So my first integral is going to go from where to where?
-2
Where?
-2 to -1.
-2 to -1. And what's on top? What's on top of that first section?
I have 2.
X squared is, right?
Yeah.
So x squared minus 4. then I have x to the fourth minus 4x squared. Okay, my second integral, I want to go from where to where?
Negative 1 to 0.
Negative 1 to 0. Very good, mate. And this time, what's on top?
X to the 4th.
X to the fourth is on top. So you should have it set up something like this. After I get it set up, what do I want to identify? What F1 and F2 are. So what is the x squared minus 4?
X2.
F2, and the other one is F1. So the first integral is going to be F2 minus F1. The second one is going to be F1 minus F2. Now, if this is all I had for the setup, my setup would be wrong. What's missing from this setup?
Times 2.
Times 2. Put parentheses around this whole thing with a 2 out front. Okay? So now we're ready to punch it in. So control doc, new page. This time I want a calculator page. So I'm going to do 2, and then I'm going to do parentheses, and then shift plus. My first one goes from negative 2 to negative 1. What needs to come first?
Two.
F2 with an X inside of it. Minus, that means F1 needs to come second with an X inside of it. And X there, get outside of it. Plus, my second integral goes from where to where?
Negative 1 to 0.
Negative 1 to 0. Okay, which one needs to come first?
F1.
F1 minus F2 with an X in it. Press enter. We have our solution.
Simple.
So our answer would be 8. So the area of those three regions would be 8. All right, so we looked at finding area of regions when I'm in terms of y. What's the process if I'm in terms of y?
Set them equal.
Set them equal.
Pick which one's right.
And how do I know which one's right?
How right it is.
Plug something in, that'll tell you which one's on the right. Okay, and then we're evaluating it just like we did yesterday. If I'm using the calculator, what do I do first?
Graph.
Graph them,
Figure out starting stuff
find the intersections,
and which other ones I'm used.
right? Then you want to set them up. Make sure when you set them up, you want to label what?
F1, F2.
F1 and F2, plug it into your calculator, gives you your answer, make sure you have 3 decimal places. Questions? Good. Front side of your worksheet is going to be like the first 2 problems. The back side of the worksheet will be the calculator problem.